Okay, this lesson is on solving proportions. Okay, we're going to look at a few methods for solving proportions. There's one that I think's easier, but then there's another method that may be necessary in certain circumstances. So, first thing, let's figure out what we're doing. When we're solving proportions, we're trying to find the variable, which in this case is x. Okay? One way you can do it is to find an equivalent fraction. That's all that it is two ratios that are equal to each other. But some cases that won't work because you may have decimals and other things of that sort. That will be hard to do that. So, first method, you are going to cross multiply the two numbers that you can. For example, we're going to multiply 5 times 21 because 7 times x is not going to give us a number, it's just going to give us 7x. So we're going to multiply 21 times 5 because we can, and we get 105. Then, after you multiply that, you're going to divide by the other number. So, whenever you do that, it'll be 105 divided by 7, which will give us 15. So, x is equal to 15. Okay, here's the same problem using method number 2. In this case, you're going to cross multiply both things. So, you'll have 21 times 5 equals to 7 times x. Cross multiply to get two cross products. Simplify that, that'll give us 105 is equal to 7x. And then here you have a one-step equation. So to get rid of 7, we divide by 7 on both sides, and we get that x is equal to 15. If you have no idea how I got 15 from that, go back to watch my one-step equation or two-step equations video. So we get the same answer, different method. Okay, so we're going to look here at example number 2, and the best method to use in a problem like this, you can either do simplify equivalent fractions, or you're going to cross multiply what you can, which is 6 times 5, which will give us 30. Divide by what's left, which is 12, and 30 divided by 12 is 2.5. So y is equal to 2.5. That's all you do, cross multiply, divide by what's left. Okay, example number 3 is the type of problem that we will not be able to just cross multiply, divide by what's left because we have a complex kind of fraction here. So we're going to have to use the other method where we cross multiply both cross products. So we'll have 40 times 6 is equal to, then you have 15 times z plus 1. And I put this z plus 1 in parentheses because this is its own separate unit. And you also see that we can use the distributive property to simplify. So all we did was just cross multiply to get two cross products. 40 times 6 is 240. And when you do the distributor property here, we get 15z plus 15. Now we have a two-step equation. First thing we have to do is get rid of that 15, because remember we're trying to find z here. We're trying to find the variable. So we're going to get rid of this 15 first, and to do that we subtract 15 from both sides. Now that we did that, we get 225 left on this side, 15z on this side. Now, to get rid of this 15, we divide by 15, and we get z is equal to 15. If you don't know what I did there, you need to go back and watch the two-step equation video. Okay, go ahead and jot these down for future classwork and another example. You're going to need to know these things. In the next example, we're going to be using the second conversion. You need to know that a mile is approximately equal to 1.61 kilometers. Okay, so here we're going to write and solve a proportion to complete the statement. Round to the nearest hundredth if necessary. So, we want to know how many miles approximately is 6 kilometers. Well, we know that from the previous slide, 1 mile is equal to 1.61 kilometers, or approximately equal to. So, we're going to set up a proportion. Remember, we want to match kilometers with kilometers, miles with miles. We want to find out how many miles is in 6 kilometers. We are going to here cross multiply get 6, divide by what's left, and we get 3.73. So, 6 kilometers is approximately equal to 3.73 miles. Okay, try these on your own, see what you can do.